Good day, my dear students. Today we are going to take a look at examples still on the sum of geometric progression or geometric series. Take a look at this example 9. So the first and the last terms of a geometric series are 2 and 2048 respectively. The sum of the series is 2730. Find the number of terms and the common ratio. Solution. You know that A is equal to 2 and the L is equal to 2048 and the Sn is equal to 2730. 2730. We have to find number of terms, but recall that Tn is equal to Arn minus 1 and this is equal to L. This implies that Tn, which is equal to A, is 2r raised to the power of n minus 1 is equal to 2048. So if you divide through by 2, you are going to have r raised to the power of n minus 1 will be equal to 2048 divided by 2. That's 1024. So r raised to the power of n minus 1 is equal to 1024. But you also know that by indices, this implies that r raised to the power of n times r raised to the power of minus 1 is equal to 1024. And r raised to the power of n all over r will be equal to 1024. So r raised to the power of n will be equal to 1024r. And that's equation 1. If you go to the second part of the question, that Sn is 2730, you're going to have that Sn is equal to 2730. Implies that Sn is equal to A using A brackets r raised to the power of n minus 1 all over r minus 1. This is equal to 2730. So 2 bracket 2 raised to the power of, don't know the r yet, r raised to the power of n minus 1 all over r minus 1, and this will equal to 2730. When you divide through by 2 will cancel this one. This will be 1365. Can you confirm that? That 2730 divided by 2, 1365. So r raised to the power of n minus 1 will be equal to all over r minus 1 will be equal to 1365. When you cross multiply, let me write it, cross multiply plus 1365. Sorry about that. So if you can take a look at that again in this line now, that will be r raised to the power of n minus 1. Okay, let's say will be equal to 1365r minus 1365 plus 1, and this will be 1365r minus 1364. So but r raised to the power of n is that. When you substitute, that means that 1024r will be equal to 1365r minus 1364. If you collect like terms, so that 1024r minus 1365r will be equal to minus 1364. So if you do that subtraction now, let's see where it will lead us. 1024 minus 1365. So you are going to have that minus 341r will be equal to minus 1364. Divide both sides by that. R will be equal to minus 1364 all over minus 1 minus 3 0.41, and that will give you 4. That will give you 4. So therefore r is equal to 4. So we need to get the number of terms. But from equation 1, r raised to the power of n is equal to 1024r, and this implies that r raised to the power of n will be equal to 1024 times 4, which is 4096. So r raised to the power of n is equal to 4 raised to the power of 6. 4 raised to the power of 6. Can you confirm what is going to be? 4 raised to the power of 6. Or, yeah, 4 raised to the power of 6. So r raised to the power of n is equal to. So when the base, so it simply means that n is equal to 6. That's 4 raised to the power of n. We already gotten r, that 4 raised to the power of n is equal to 4 raised to the power of 6. So n is equal to 6. So in conclusion, r is equal to 4. Therefore, r is equal to 4. N is equal to 6. So let me give you exercise here to try. So you try this exercise. The same pattern, but different. And just change the first and last terms of a GP series are 3 and 768. 3 and 768. If the sum of this series is 1533, calculate the common ratio and the number of terms. So this is where we're going to end it for today. Thank you.